Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our remove file int, our remove file double, and our remove file char. Each one of these functions allow for you to remove a single instance of a piece of data from the file. And so in this particular example, we're going to start off looking at our integer example, and particularly at our ints.txt as a sample file. So the idea is I want to be able to pass to this function a integer, rather first the file name and then an integer. And if it finds an instance of that integer in the file, it simply removes it from the file. And specifically, it removes only one instance, and it actually turns out to be the first instance of that value in the file. Now, how do we go about doing this? Well, there's a couple of ways that you can do it. One is you can load the entire file into memory and then sort through an array. However, though, that becomes very cumbersome as the files become larger. An alternative is that we simply open a file for reading and open a second temp file for writing. As we read the data in, we check to see if we found a match with the data that we're looking for. If a match is found, we simply don't write that data to the temp file. Any other data gets written to the temp file. Once we have completely read through the file, then we simply turn around, we close both files. We then copy the temp file over to the original file. We would also want to, before we do that, to delete the original copy. So let's go ahead and get started with this. To begin with, I'm going to need two file pointers. So an input file and an output file. And what I want to do is I want to first open my input file by using fopen. And in this case, we're going to pass the input file name, and I want to open that for reading. And if for some reason I fail to open the input file, so in other words, if my input file is not equal to null, I want to do something. But if I fail to open it, in other words, that is equal to null, then I simply want to printf a message, error, failed to open %s. And then, of course, follow it with a new line and specify which file we failed to open. Now, assuming that we were successful and that our input is not equal to null, then what we can do is turn around and open our output file. And our output file, we can actually hard code the name in this since it's just going to be a temp file. So in this case, we're going to fopen a temp.txt. We want to open it for writing. We can once again check to make sure that our output file is not equal to null. And if it is equal to null, then we simply provide a message that says error, failed, rather a printf with a message that says error, failed to open %s. And then provide it the name of our temp file. Now you could also do this in one statement here. As a matter of fact, you don't need the placeholder. We could simply go so far as to say failed to open temp.txt. Either's fine. I just get into the habit of using my format specifiers. Okay, so in the event that the output file is not equal to null, and the input file is not equal to null, we simply want to read the contents of the input file and write it to the output file. And to do that, the only thing we need to do is use fscanf We want to use our input file pointer, and we want to specify the format spec that must match the data type. In this case, it's going to be a %D. And we want to have a temporary variable to store that data in. And so in this case, I'm going to create a variable called chunk. And we want to do this while it is not equal to end of file. And so before we get too far ahead of ourselves, let's go ahead and create that temporary variable. It's going to be an int. We're going to call it chunk. And essentially what we're going to do is we're going to check to see if chunk is equal to the data. If it is, we ignore it. Else, we write it to the file. And what does that mean? Well, we simply use fprintf, and we specify the output file pointer. We specify the format spec associated with, in this case, an integer, followed by a new line, and we simply write the chunk to the output file. At this point, we just need to do a little cleanup. Namely, we need to make sure that we close our output file. We also want to make sure that we successfully close our input file. So in other words, what you want to do is you want to make sure that you have the fclose in the correct location to close only if you have successfully opened the input file. And now what we want to do is we want to figure out how do we get now the modified data or the temp.txt back to the original file. Well, we could open the files again, except this time in the reverse order, meaning that the temp.txt is our input and our original file name is our output. But I thought for a little bit of variety, we'd look at some additional functions. Particularly what I'd like to do is I'd like for us to look at the remove function. And the remove function allows for us to remove a file from the system. And so if you pass it a file name, if the file exists, it removes it and the function returns 0. Likewise, I'd like for us to look into another function called rename. Rename allows for us to rename a file from its old name to a new name. So let's give those a shot. The first thing that I want to do is I want to remove the file. And particularly what I want to do is I want to remove my input file name. And what we can do is we can check to see if that was in fact successful. And so if you recall from the Wikibooks page that I just pulled up, the remove function will return 0 if it is successful. So what we're going to do is we're going to leverage this by saying if remove input file name is equal to 0, well, then what we want to do is we want to figure out how to rename the temp file back to the original file. So essentially what I'm going to do now is I'm going to specify the same name, the tmp.txt, and I'm going to rename it back to whatever my input file name was. And essentially what that does is that returns the file back to its original name, missing the data. Now, with the remove, with the rename function, we also have an integer return value, and particularly the 0 is returned upon success. And so at this point, what we can do is we can also go ahead and check to make sure that our rename worked. In this case, if rename is equal to 0. And at this point, we probably want to create a little bit of noise, meaning that under each one of our ifs, we want to indicate what happened. So for instance, if our remove fails, in other words, if it's not equal to 0, we want to printf error failed to remove %s, followed by a new line. And in this case, it would be the input file name. If under the rename, we manage to somehow get a value other than 0, we would want to printf error failed to rename temp.txt as %s. And in this case, the %s is also going to be the input file name. Once again, we're providing some information on the command line back to the user. And in this particular case now, when the rename function does work, we can decide what we want to set as our return value. In other words, if we reach here, this is where we want to set results. All right, and so ultimately, this would mean that results are equal to 0 or 1. Okay, so we're going to start off by setting the results equal to 1, and you'll see why in just a second. Now, the last question that we want to look at is, how do we determine whether or not we have to bother removing and renaming the file? Well, what we can do is inside of our remove file int, particularly inside of our while loop, as we are copying the data over, if we never see the data, there is no need for us to overwrite the file. In other words, to remove and rename. So it would be really useful if we utilized our results variable here. So we initialize it as 0, and then once we find a match of our chunk that matches our data, we simply say results equal to 1. Now, if you come down here to this block, where we are removing the original file and then renaming the temp file to the original file, the only reason that we would have to do this is if results is in fact equal to 0. In other words, we found data that needed to be removed from the file. Otherwise, our original file and our temp file are identical. So what I'd like to do here is make just a slight change where I check to see if results equal to 1. And if results are equal to 1, we simply move our remove and our results inside of this if statement. So give me a second to clean this up, and then we'll review it one more time. Otherwise, under the else, this just simply means that there was no reason to remove and rename. So let's think about this one more time. If no match to our data was found when we were looping through our input file and writing to our output file, there is also no reason for us to turn around and remove and rename our temp file. Now we still have one other problem here. So if you notice, my fclose input is all the way out here. And we're attempting now to remove and rename a text file that may potentially still be open. So what we can do is we can move our F close closer to our open. In other words, we can move it inside of the if branch of this statement here. In other words, we may find ourselves closing the file earlier than we had expected. And so particularly, when do we in fact need to close our input file? Well, the answer is we need to close our input file as soon as we are done reading from it. So in this case, what I'd like to do is I'd like to put our fclose input right after our while loop. And this kind of makes sense because essentially at this point, we should be done with both our input and our output files. The only other thing to note here is to make sure that we also close the file if the case occurs where the output file is in fact null. So as a precautionary measure, we would want to go ahead and copy our code to the else branch where we failed to open our output file, but did want to make sure that we closed our input file. A little bit of code redundancy, but in this case, it's somewhat inevitable unless we want to move this entire block of code outside of our outer if statement. All right, so hopefully that's clear. Let's go ahead and build this and let's see if it works. First, let's see if it compiles. All right, so that looks promising. I want to come out here to my command window, and specifically, I want to try our ints.txt. So just for good measure, I'm going to come back in here to my ints.txt. I'm going to add a duplicate value in here, another duplicate value to see how well this works. And I'm going to add another 1 in there. So basically at this point, I have a 1 at the top of my file, and I also have a 1 at the bottom of my file. And what I'd like to do now is I'd like to do a remove. And specifically, I want to remove something from ints.txt. And if I hit enter, I come back over here, you'll notice that I have in fact removed both of my 1s. This was not what we wanted to do. Instead, we only wanted to remove the first 1 and only 1. Well, that's easy enough for us to fix because if you recall, we flipped a switch. In other words, we set our results equal to 1 once we found a duplicate. Well, at this point then, what we can do is we can stop removing data once results is equal to 1. So in other words, if our chunk equals data and results equal to 0, the original value for results, then and only then do we want to ignore it. This is precluded by the fact that we initialize results equal to 0. So in other words, we're going to write the data if either of these conditions are false. All right, so let's go ahead and build this. We, of course, need to go back and add in a couple of pieces of information here. We'll go ahead and add an int back in. We'll go ahead and add another 5. So we've got a duplicate value in there. And we should have a 5 now at the top of our file as well as a 5 at the end. So what we can do now is we can try to remove one of our 5s and see what happens. And this time around, we only delete the first 5. And if we run it again, we now delete the second 5. And more importantly, if we continue to try to delete 5s, nothing happens. Also, you'll notice that if I do a dir or look at the current directory, you'll see that I have my temp.txt there. And my temp.txt turns out to be a legacy copy of the last file that I have been working with. Note that that is not universal behavior, so you'll want to check the system that you are ultimately running your code on. Worst case scenario is you revert back to the method of simply copying the data from one file to another and then deleting the source. Now, we have our remove file int working. What we want to do now is we want to focus on the remove file double and the remove file char. As you would expect, there is not a significant amount of difference between these methods. And so what we can do once again is simply a very careful copy and paste. Particularly what we want to do is we want to focus on everywhere we had specified an integer. Specifically in our chunks are supposed to be a double. We want to make sure that in our printf we reference the remove file double. We can still use the temp.txt. However, we do want to change the format spec to a %lf as well as %f for the output. Please note that you want to make sure that your %f here matches your %f in your add file double. And then likewise, everywhere there was any reference to a double, through to an integer, you want to make sure and change it. And we'll do the same thing now for our char. Once again, we simply just paste a copy of this, and then for our chunk becomes a char, and our remove file int becomes remove file char. The %d simply becomes a %c. And at this point, unless we've missed something, we're probably done with all of our removes. So let's go ahead and build it. Let's see if we have any issues. Doesn't seem like it. So let's give the rest of these a shot. And one that I did not run earlier was my add chars. So let's give that a shot. So I'm going to add chars, and I'm going to add the letter X. All right, looks promising. If I do a dir, you'll see that I now have a chars.txt. How about if we add a Y, maybe a couple of Ys, followed by another X, and then maybe a Z. And you'll see that my chars.txt is now 18 bytes. And I want to drag and drop my chars.txt in there. Looks good so far. And what we want to do now is we want to test the ability to remove from our chars.txt. Why don't we first do something we haven't yet done? Why don't we try to remove a character that we know does not exist? So we'll just put a in here. And you'll see nothing happened to our file. Still the same. But we want to go ahead and check, for instance, an X. And you'll notice now that it has removed. We seem to have a character issue. All right, there is one little minor change here. Let's see here. When we are reading in our characters, we seem to also be inadvertently reading in our new line and processing our new line. Perfectly fine. A little bit of a minor tweak we have to make here when it comes to the characters. So what we can do here is a little bit of experimentation. We can attempt to parse it with our fscanf, or what we can do is we can simply ignore it if we see it come in as a chunk of data. So the easiest thing for us to do is simply to provide it with a new line when we are using our fscanf. And this simply limits us to a single character per line. And what we're going to do is we're going to go ahead and rebuild it one more time. I'm going to go ahead and delete my chars.txt so that we can start over one more time on our test. We want to go ahead and add a few letters to our file. We'll start off with an X, maybe a couple of X's, followed by a Y. Let's make those 3 Y's, and then a Z. And at this point, then you should have each character on its individual line. And then when we do a /remove, and we'll focus on the character Y, you'll see that one of my Y's has disappeared. I had 3 originally, just to prove that that worked. I'll run it again, and I should now have just 1 Y left. And just to be sure that I'm not pulling any tricks, I'm going to do my Z, and now my Z is gone, and so on. So now we have our remove file char, our remove file double, and our remove file int all working. The only question or additional feature that we might want to consider adding to this is what would happen if we, in fact, deleted all of the characters in the file. Well, what you could do is you could simply add an extra variable here, a counter variable. And as you pulled a chunk out of a file, you would simply keep track of the number of characters that were pulled out. And if a chunk matched a piece of data, in other words, we were asked to ignore it, you would simply decrement the count. So in this case, then you would add 1 when you pulled it out of the file, and you would subtract 1 when you chose to ignore it. At this point, you could simply put another if statement that said, if my count was equal to 0 at the end of this process, I simply remove my source file. In this particular case, our customer, or in the requirements, didn't ask for us to do that. So what we have here is fine, but just be aware that it's a pretty easy thing to do. So once again, hopefully you found this video useful in all of its flaws and a little bit of troubleshooting. As always, if you've got any questions or comments, don't hesitate to email me, and thank you for watching.